Wells Fargo fraud prediction. In this presentation, data scientists use predictive modeling to detect fraud in the digital payments landscape. Data scientists will use predictive modeling to inform consumers of fraud and preempt certain transactions and monetary losses. Elder adults are vulnerable to cyber attacks from people who intend to commit fraud. Banks must be able to recognize and prevent financial exploitation. Since most transactions do not consist of fraud, a machine learning model must be powerful enough to predict the small cases of fraud that do exist. Especially during the pandemic, most banking has transitioned to the digital sphere. Banks need to protect the most vulnerable populations against theft. Financial abuse can go undetected without well-developed machine learning models. It is in the bank's best interest to develop machine learning models to prevent monetary loss. The machine learning model developed by data scientists will consider past payment history, internet activity, location, and timestamps to determine whether bank activity is considered fraudulent. The exploratory data analysis revealed that the data set was imbalanced. The data scientists relied on a combination of evaluation metrics to deal with the imbalanced data set. F1 score and accuracy were both considered when choosing the best model for detecting fraud. 67% of the dataset was non-fraud and 32% of the dataset was fraud. There was no significant multicollinearity in the dataset. The data was initially 14,000 rows by 24 columns for the training data. There were several missing values in the dataset for carrier name, region name, device type, customer state, and state province. Data scientists filled in missing values with the most common names in each column. The most popular carrier name was Cox Communications. The most popular region in the data was Southwest. The most popular state was California, and the most popular device type was mobile. %20 of the data was lost when the column phone number update timestamp was dropped. The final data shape was 10,753 rows by 32 columns. The data was then transformed using date time and converted into ordinal characters before modeling. For hyperparameter tuning, grid search CV was used, as well as date time transformation, one-hot encoder, and label encoder.
Hi, my name is Kevin Stewart, and I will be discussing data splitting, model building strategies, and hyperparameter tuning. Due to our sparse data input, the data was normalized using the max ABS scaler. 80% of the data was used for training, and a holdout set of 20% was used for testing the data. In our model building strategies, our goal in mind was to predict suspected elder fraud. Our first model used was linear discriminant analysis because its effectiveness in predicting category membership. Our second model was support vector machines. The support vectors are able to maximize the margin. Next, we use the KNN algorithm. We use Euclidean distance measure to take the average to make predictions. Model 4 was logistic regression because of its ability to estimate probabilities for prediction. We then looked at decision trees because of its ability to segment the data. The sixth model that we looked at was the naive Bayes algorithm, which was a good choice for this type of data because we are using independent customer transactional data, and the naive Bayes algorithm has an assumption of independence. The seventh model we looked at was the neural network, which we used because it could find unseen patterns in data that might be hidden. I will now look at some of the steps we took in tuning our parameters of our algorithms. For hyperparameter tuning, we use grid search CV to help us decide the hyperparameters for our decision tree. We had a best estimated score of approximately 0.88. In tuning our random forest model, we had a minimum split of 300 and used the entropy as our impurity measure. The number of samples to decide a node was based off a minimum sample of 100 splits. In tuning the naive Bayes model, we use an alpha of 0.1 to control how the model is formed, and this was determined by using grid search CV. We also applied the Laplacian smoothing method, but it was ultimately removed because it did not enhance the model. In tuning our neural network model, we used a solver of LBFGS, also known as Limited Memory Broyden-Fletcher Goldfarb-Shannon, because it only stores the last several updates. We also use a max iteration of 100. This concludes my section on hyperparameter tuning. I will now pass it over to Kevon Cambridge.
Hello, my name is Kevon Cambridge. This section describes the results and model selection of our constructed models. Since the dataset we use can be imbalanced dataset, we use F1 score as a primary metric for comparison. We also want to accurately predict a fraudulent activity based on multiple factors. Therefore, the accuracy metric was used. For our first model, we have bagging. We see that it has an accuracy of 87%, which can be seen right here, which is somewhat good. We want our models to have at least an accuracy of 92%. We also see that the F1 score is 87%, which can be seen right here. This means that most of our label is correctly labeled as a fraudulent activity. As we can see for our training results, for fraudulent activity, the training result predicted 1,394 fraudulent activities correctly and 484 incorrectly. In our testing result, it correctly predicted 317 correctly and 160 incorrectly. This model did not meet our requirements. We can say the same for our neural network, random forest, ADA boost, k-nearest neighbors, and linear discriminant analysis models. Even though all these models performed fairly well, it did not reach the requirements. As you can see, for our neural network model, we receive an accuracy of 91% and an F1 score of 91%, which is probably the best model that did not meet our requirements. As you can see, in the training results, it received a 99% accuracy with predicting 1,877 fraudulent activity correctly and 1 incorrectly, which is really well. And in our testing set, it predicted 410 correctly and 67 incorrectly. This model performed really well, but it did not meet our requirements, so we did not use it. And for a random forest, which is our model that performed the worst, it has an accuracy of 69% and an F1 score of 59%. And as you can see, it correctly predicted 902 correctly and 976 incorrectly. And remember, we said that we want our model to predict more fraudulent activities correctly than incorrectly. As you can see in our testing result, again, it correctly predicted 30 and incorrectly predicted 447. For our ADA boost, we see that it has an accuracy of 90% and an F1 score of 89%, and in our training result, it correctly predicted 1,878 correctly and 0 incorrectly, which is also good. But in our testing set, we see that it predicted 377 and 377 correctly and 100 incorrectly. For our k nearest neighbors model, we see that it has an accuracy of 83% and an F1 score of 81%. In our training result, it predicted 1,164 correctly and 714 incorrectly. For the testing, for the testing result, it predicted 254 correctly and 223 incorrectly. For our LDA model, we see that we have an accuracy of 76% and an F1 score of 74%. In the training result, it predicted 1,185 correctly and 693 incorrectly. In the testing result, it predicted 195 correctly and 282 incorrectly. We can also see from the gains chart how each model performed. You can see that our logistic regression, which we'll talk about in the next slide, is performed really well. As you can see, it has a lot of cumulative gains and so forth for each of these models. For our model selection, we have 4 models that reached our requirements. These models are logistic regression, naive Bayes, support vector machine, and decision tree. The reason why these models were chosen is because not only does these 4 models reach our requirements of 92% accuracy and a really good F1 score, they also perform really well on both the training and testing sets. We decided to pick the naive Bayes model as our best performing model because it has the highest accuracy and F1 score, and it accurately predicted all values correctly on the training set and gave us 93% accuracy on the testing set, as you can see right here. To conclude, we would suggest Wells Fargo to take into consideration of implementing the naive Bayes model, as each day someone is a victim of fraudulent activity. This can potentially help reduce or stop a fraudulent activity from happening. Thank you.